Okay, this is Algebra 1, Lesson 28. We're going to talk about fractional parts of a number and functional notation. So let's start with fractional parts of a number. When we multiply a number by a fraction, we say that the result or the answer is a fractional part of the number. So we multiply 7/8. Whoops, wrong line here. Multiply 7/8 by 48, we get the answer is 42. Okay. When we say that, we say 7/8 of 48 is 42. So we can generalize it to say F times of equals is. So the book likes to use this terminology, and I don't. I use it a little bit differently, but this will work too. We can learn it both ways. So let's look at an example. This example 28.1. This is 3/4 of what number is 69? We're going to use WN for what number and WF for what fraction. So they said, if you got that sitting there, so 3/4 is your fraction of what number equals what? Equals 69. Okay? So then, basically, we're solving for 3/4. So we're going to multiply both sides by its reciprocal. And we get WN equals 23 times 4, which is 92. Okay? So let's look at example 28.2. It says, what fraction of 40 is 24? So, what fraction of 40 is 24? So we can substitute this for just a variable, x. I'm going to do f. F times 40, replace this with equal is 24. So how do I solve for this? I divide both sides by 40. And I said f, and I can reduce. This becomes 6, and this becomes 10, and then this becomes 3, and this becomes 5. So my fraction is 3/5. Okay? Let's look at 28.3. Just because we have a mixed number doesn't mean we do any different. It says 2 1/2 of 240 is what number? Well, then I simply replace this. I'm going to change this to an improper fraction because I'm doing multiplication. Times 240 over 1 equals n. I simply do 1. So n is 600. That's all it is. So fraction of a number is the part of you replace with times, and is you replace with equal. And then you simply just solve for whatever variable is missing. Are you missing the fraction, the whole number, or the part? Okay? So now let's look at function notation. This is a little bit trickier. It's more about terminology here. So we'll begin our study of functions by introducing functional notation. So let's look at the algebraic expression. This is an expression, x plus 2. Pretty simple, right? So we said it has exactly one value for any real number that we choose for the replacement of x. If we replace x with 5, we get 5 plus 2 equals 7. Yes? If we replace x with 0, we get 0 plus 2 is 2. And we replace x with negative 75, we get negative 73. Yes? So if an expression is the only in which the only variable x has exactly one value for any value of x, we call the expression a function of x. So since x plus 2 has only one value for the replacement value of x, we can say that x plus 2 is a function of x. So if we write the equation, well, y equals, we say y is a function of x. If we replace x with 5, 0, and negative 75, like we just did, we replaced it with 5 here, okay? We replaced it with 0 and negative 75, and we got, what? 7, 2, and negative 73, yes? So we said y equals those. So, and mathematicians have found that if we use f of x instead of using y, we can read the following equation to say f of x equals x plus 2. That's the same thing as saying y equals x plus 2. We just replace the y with f of x. All right? This form is called functional notation. You need to write this down in your notes. Functional notation. We do not have to restrict ourselves to just F. We can use different letters of the alphabet. So let's look at the next example. Let's use 3 different equations. So I have y equals x plus 7, y equals x squared minus 2, and y equals 2x cubed minus 3. Okay? If we ask someone to find the value of y when x equals negative 3, are we going to know which one to put it in? No. It could be put in either one of any of the 3. So let's give them different names. All right? So let's call this one f of x equals x plus 7. G of x equals x squared minus 2. And h of x equals 2x cubed minus 3. So now I can say, we have named the functions g, h, and f. I can say, we're asked to find h of negative 3. I'm going to put in the h of x. So I have h of x equals 2x cubed minus 3. And then I want h of negative 3, which is 2 times negative 3 cubed minus 3. H minus 3, or h of negative 3, equals 2 times negative 27 minus 3. And h of negative 3 is equal to negative 57. So in this example, we can see 3 different benefits for using function notation. The first line identifies which equation to use, which one to replace x with. Okay, because we identified h of x. The second and third tell us we replace x with negative 3. We put in the equation. And then the last line tells us h of negative 3 is equal to negative 57. So that's why we use functional notation, to use these different formats. So in essence, a functional notation problem is exactly as the evaluation problems we were doing earlier. So let's demonstrate. Let's look at example 28.4. Okay. It says, evaluate x times x squared minus 3x if x equals 2. So we have 2 times 2 squared minus 3 times 2. So 2 times 4 minus 6. 2 times negative 2, which is negative 4. So it's simplified. Yes, we've been doing these problems. We just simply replace x with 2. Now let's look at 28.5. And it said f of x equals x times x squared minus 3x. Find f of 2. So basically you're saying f of 2 equals 2 times 2 squared minus 3 times 2. So f of 2 equals 2 times 4 minus 6. F of 2 equals negative 4. And isn't that what we got the first time? It is exactly what we got the first time. Negative 4. So let's look at another example. So basically the function notation is just like the evaluation that we were doing before. So let's look at one more example, 28.6. Says evaluate x squared times 2x minus 1 if x equals negative 2. So we're going to replace x with negative 2. So we're going to say negative 2 squared times 2 times negative 2 minus 1. So this becomes 4 times negative 4 minus 1, which is 4 times negative 5, which equals, negative 20. Okay, so I'm going to write that over here. We got negative 20 for that one. Now let's look at it in functional notation. So we say if g of x equals x squared times 2x minus 1, find g of negative 2. So we're doing the exact same thing, except for now we're calling it functional notation. So we simply say g of negative 2 equals negative 2 squared. 2 times negative 2 minus 1. G of negative 2 is equal to 4 times negative 4 minus 1 equals to 4 times negative 5. And then we can say g of negative 2 equals negative 20. As simple as that. We get the same thing. So your code for this homework lesson, I want you to put code 369 on homework number 26. Just put at the top of the page. Number 369 at the top of homework 26. Okay?